Today we are going to be talking about 2.3b, compound inequalities. Today is going to be a quick lesson that is directly related to the work we did yesterday. We are doing with compound inequalities. With compound inequalities, we are referring to more than one inequality represent the same scenario. So for our purposes for number one right here, so you'll be able to look at this on your homework. But for number one, we look at 11x minus 7 is less than negative 40. Or negative 7 plus 12x is greater than 125. With an or statement, we are trying to find inequalities that work for one or the other one. So there are a lot of possibilities here. In order to find those, we're going to take each inequality and solve them separately. So just like we did yesterday, I'm going to show 11x minus 7 is less than negative 40. We look at what is the story of x. What are the operations that happen? So x is being multiplied by 11 and then subtracted by 7. So therefore, I'm going to get rid of the subtraction as my first step and then do division as my second step. That is my backwards work. So adding 7 to both sides, I have 11x is less than negative 33. Now that I have 11x is less than negative 33, I can do my division. So x is less than negative 3. So that's my first inequality. My second inequality was negative 7 plus 12x greater than 125. To work on this one, again, the same thing is, what's the story of x? It is multiplied, followed by subtraction by 7. So I'm going to add 7 to both sides, so that 12x is greater than 132. Divide both sides by 12, and I get x is greater than 11. Now again, this statement was an or statement. Together in the end, they are x is less than negative 3 or x is greater than 12. Back to my number line, I'm going to represent all of these. This is going to look different from yesterday's inequalities, but we're still applying the same concepts. Since I'm doing less than for x is less than negative 3, that gets an open circle on negative 3 and an arrow to the left. We also want to put in x is greater than 11, so that is going to be 11 with an open circle and an arrow to the right. The main difference here with these inequalities compared to the ones yesterday is that I have solution sets that go in opposite directions. So for example, if I wanted to pick something like negative 6, negative 6 is going to be a solution for one of these inequalities, but not the other inequality. So negative 6 is still a part of our overall solution because it satisfies one of the inequalities. Positive 14. Positive 14 is also in our solution because, again, it is part of one of them. It will not work for both my inequalities, but it does work for one of them, so that counts in this statement. If I look at anything in between, so that is less than 11, greater than negative 3, all of these numbers, this is my not a solution area. So these are the numbers that do not satisfy either inequality. If you try to plug in 4 into the original inequality on both of them, it will not work either way. So ors can go opposite directions. There are other possibilities, but for our purposes, we're going to focus on these type that go opposite directions. So we would shade both inequalities. Let's look at number 4. Number 4 is called an and statement. Whoops. It's just going to be an and. If I don't write this on there, this is actually the same as doing this. Negative 46 is less than negative 6 minus 8x, and negative 6 minus 8x is less than or equal to 90. When it's an and statement, we can write it as one compound inequality instead of two, but they mean the same thing. So one of our strategies is we can write it as two separate inequalities, and now we just solve like we normally do. So x is being multiplied by negative 8 and then added by a negative 6, so I'm going to add 6 to both sides. So I have negative 40 is less than negative 8x. Divide by a negative 8. Positive 5, remember, if I divide by a negative, I gotta flip my symbol, so 5 is gonna be greater than x. When I look at the other one, I'm going to add 6 to both sides. So that negative 8x is less than or equal to 96. Now I can divide by negative 8. Since, again, I'm dividing by a negative, so x needs to flip my sign, and x is going to be greater than or equal to negative 12. So this is together as an and statement. Well, just like my first problem, I am allowed to put these together as one inequality. When we write our compound inequalities with an and, it's best to start with the lower number. So x is greater than or equal to negative 12. I can rewrite that as negative 12 is less than or equal to x. Well, x is also, when I look up here to the other inequality, 5 is greater than x, but that's also the same as saying x is less than 5. You can leave an and statement as two separate ones as long as you write and, or you can put them together as one. Either way is fine. So now when I go back to my number line, I want to graph this. Negative 12 is a less than or equal to x. So that's going to get a closed circle. 5 is x is less than 5. So that's going to get an open circle. In this scenario, we are only concerned with the values that work for both inequalities. Previous example with or, it just needed to work for one. Here, we need to work for both. So that's why we shade everything in the middle, and we don't go beyond. So for example, negative 13 is not a solution. Okay, just like 6 is not a solution. Okay, if you try to plug in those numbers into our inequalities, they are going to work for one inequality, but not both. So it needs to be true for both of these statements. For example, negative 6. If I plugged in negative 6, it will be true for both of them. So let's do a quick check of those and try those out real fast for our solution sets. So if I do negative 13, so I have negative 46 is less than negative 6 minus 8 times the negative 13. So negative 46 is less than negative 6 plus 94. Negative 46 less than a positive 86. That's true, so that is a yes. If I go for the second inequality though, and I do negative 6 minus 8 times the negative 13, I'm going to check, is that less than or equal to 90? So this is what we're testing. Is it less than or equal to 90? Well, from my previous problem, I know that 86, oh, hold on a second here. Trying negative 13. Oh, I'm sorry. Sometimes Mr. Grant makes a mistake, and that's right here. Negative 8 times the negative 13 is not, it's not 94, it is 104. Whoops. So on the left side, we're still okay because it comes up with the same thing. We have negative 46 is less than 98, and that is true. However, when I do it on the right side, I get a positive 98 less than or equal to 90. So it's true here, it's not true here. That's why negative 13 is not in the solution set. The same thing would happen with a positive 6. If I did anything in the middle, and I'm going to pick an easy one like 0 actually. If I plug those in, so I have negative 46 less than negative 6 minus 8 times 0. And that's going to give me negative 46 is less than negative 6 plus 0. Is negative 46 less than negative 6? Yes. Whereas if I come over to the right side, I do negative 6 minus 8 times 0. Is that less than or equal to 90? Well, this turns into 0 or negative 6 is less than or equal to 90? Yes. That's why it is part of the solution set. This is all we have for today for compound inequalities. I want you to answer the quick follow-up questions, and we will continue our inequalities tomorrow.